everyone. This problem has been asked in GATE 2023 and this problem relates to the control system part. And the problem is that consider a lead compensator of the form Ks is equal to 1 plus S divided by A divided by 1 plus S divided by beta A, where beta greater than 1 and A greater than 0. The frequency at which the compensator produces maximum phase lead is 4 radian per second. At this frequency, the gain amplification provided by the controller, assuming asymptotic body magnitude plot of Ks is 6 dB. The values of A, beta respectively. So, here, so here this is given that asymptotic body magnitude plot. That means we have to take the approximate body magnitude plot. For detailed study of lead compensator, you can refer this NPTEL lecture, Module 9, Lecture 2, Design of Lead Compensator using Bode plots, and this NPTEL course name is Control Engineering by Professor Ramkrishna Pashumarthy, Department of EE, IIT Madras, and the YouTube link for this lecture is given below. Now, before we begin to solve this problem, let us have a quick background, quick recap of the lead compensator. So, as we all know that lead compensator is similar to the high pass filter and the equivalent circuit electrical circuit diagram can be made like this. For this electrical circuit diagram, if we find this transfer function V naught S divided by VIS, we will get alpha into 1 plus S tau divided by 1 plus alpha S tau, where tau is the time constant, that is R1 into C, and alpha is the attenuation factor, is equal to R2 divided by R1 plus R2, and alpha is less than 1. Generally, for lead compensator, optimum value of alpha is 0.1, and the disadvantage of lead compensator is that it creates attenuation to the system. For removing attenuation, we have to apply series amplifier whose gain value is 1 plus 1 divided by alpha. So for removing the disadvantage of lead compensator, we add one series amplifier to the lead compensator. For the for removing this disadvantage, I have shown here this block diagram. So we can make now, if we want to find the transfer function, so here we can get the transfer function without having attenuation or any gain value. For this block diagram, we get the transfer function is equal to ys divided by xs is equal to 1 plus s tau divided by 1 plus alpha s tau. Now, if we want to make these zeros and poles on the S plane, then we made like this. Since attenuation factor is less than 1, so we can say that tau is greater than tau alpha. Therefore, 1 divided by tau is less than 1 divided by tau alpha. Therefore, this 0 will be near to the imaginary axis and pole will be away from the imaginary axis. Now, we are going to make the body plot for easy understanding of this lead compensator and for visualization of the lead compensator. For making the body plot, first we substitute S is equal to j omega in the transfer function, and the transfer function will become like this, that is equal to 1 plus j omega tau divided by 1 plus j omega tau alpha. Now we will find this magnitude and phase angle of this transfer function. Magnitude will be 1 under root of 1 plus omega square tau square divided by under root of 1 plus omega square tau square alpha square. And the phase angle will be tan inverse omega tau minus tan inverse omega tau alpha. Tan inverse omega tau is the phase angle for this numerator and tan inverse omega tau alpha is the phase angle for denominator. So we can see that there are two corner frequency that occurs at 1 divided by tau and 1 divided by tau alpha. So accordingly we can say that at both corner frequencies this phase angle and this slope of this magnitude is getting changed. Therefore we can say that at corner frequency is equal to 1 divided by tau we gain the slope of plus 20 per decade, and again at corner frequency 1 divided by tau alpha we lose this slope, and the final slope will be 0 dB per decade. And we also know that the frequency at which maximum phase lead occurs will be the geometric mean of this two corner frequency. This is very important. The frequency at which the maximum phase lead occurs will be the geometric mean of the corner frequencies. So geometric mean of the corner frequency will be under root of omega c1 into omega c2. So we will get 1 divided tau root alpha. This is the frequency at which the maximum phase lead will occur. Now we will solve this problem. So we are given with this transfer function and the conditions are beta greater than 1 and a greater than 0. Since this a greater than 0 and beta greater than 1, we can say that a beta is greater than a, therefore 1 divided by a less than 1 divided by a beta. Therefore we can make the zeros and poles on the S plane where 0 is near to the imaginary axis and poles is away from the imaginary axis. Now in this problem we are given with this the frequency at which the maximum phase lead occur is equal to 4 radian per second. This is omega m is equal to 4 radian per second. So we can say that maximum phase lead occurs at the geometric mean of corner frequency. That means phi m at omega m is equal to under root of a into a beta. That means a under root beta will be 4. And this we can assume the first equation. Now another thing is given in the problem is that at this frequency we are getting the magnitude as 6 dB in this logarithmic scale. So as we all know that the slope of the line is plus 20 dB per decade. Therefore we can say that slope is equal to y2 minus y1 divided by x2 minus x1. Therefore here we can assume 2 points. First point is that a comma 0, and another point is that omega m comma 6 dB. Therefore by 2 will be 6 and x2 will be log omega m, and by 1 will be 0 and x1 will be log a, and slope is 20 dB per decade. Now log omega m minus log a is equal to 6 divided 20, and 6 divided 20 is 0.3. Therefore we get log under root beta is equal to 0.3, and this is the logarithm property that log a under root b minus log a will be, it will be divided. If we get this a into inside log, then it will be divided in the then it will divided a root a under root b will be divided by a, so we get log under root beta only. Therefore we can say that under root beta is equal to 10 to the power 0.3, and 10 to the power 0.3 is equal to 2. This is important, you can keep in mind. Therefore we can say that we get beta is equal to 4. Now using the first equation we get a under root beta is equal to 4. Therefore we also get this a equal to 2. Hence we have got the values of a and beta as 2 and 4 respectively. Therefore the final answer for this problem is B. The value of a is 2 and beta is 4. B is the correct answer. Thank you.